at a old paper to help us practice picking what distribution that each question is talking about. This is an earlier paper. They are actually a little bit harder as we go on, but I thought we'd start off with something a little bit easier than what you're going to come across, and then you develop the skills and we can move up from there. Okay, so first question is we need to think about, is this a continuous or discrete? So if we look at this, notice that it's talking about the number of milligrams. So milligrams is measured, so it's a continuous distribution we're talking about. So let's have a wee look here. Is it measured data is the first question you ask? Yes, it is. So which one is it? Okay, so if it's uniform continuous distribution, it's between a max and a minimum. If it's triangular, it's between a max and a minimum, and then they give you a peak value. And if it's a normal distribution, they'll give you a mean and a standard deviation, and they'll even tell you that it's normally distributed often. So, for example, a uniform continuous distribution might just say that whatever it is weighs between 2 kgs and 7 kgs. Triangular might be the maximum minimum time is, we can see here, is 2 hours. The maximum is 12 hours, and your peak is, looks like it's about there, 9 hours. So that's what that would look like. Whereas normal distribution, it might say the mean length is there and has a standard deviation of 1.5. So if we look at this question here, we've got a mean and a standard deviation. In fact, they actually tell us that it's normally distributed, so that's what it is. Now notice there is a second part to the question. Now if you want to work this out, you'd work out the probability of one coffee being within that range. And then if you think about it, you've got a tree coming out, haven't you? Now you won't actually need to have the tree, because basically you need one to fit in the category, then another, then another. So they're all going to end up being multiplied together. And what you're assuming is that they're independent of each other, the amount of caffeine in them. Okay. So the time it takes for a person to feel the effects of the caffeine is modeled by a random variable that takes on values between 0 minutes and 40 minutes. The most likely time is 10 minutes. So we've got a measured variable, so it's still continuous. It's one of these three. We've got a minimum, we've got a maximum, and we've got a peak. Right? Minimum, maximum, and the peak, or most likely, is at 10. So that means it is triangular. Okay, so I'm hoping that you're sort of thinking ahead of me here. Now for this other one, you're going to have to use a bit of maths afterwards to interpret. But first of all, you use the triangular distribution. Okay. A cafe owner estimates that 30% of latte coffees are made with trim milk. Over a period of a week, they've recorded how many lattes? So straight away, how many lattes are made with trim milk or other in a set of 5 consecutive latte orders? So how many is going to be 1, 2, 3, or none maybe. So we're no longer talking continuous, we're talking discrete distribution. So is this a Poisson or a binomial? So remember, binomial have a set number of trials with a probability given, and Poisson have an average given, which is discrete per continuous, something counted per something measured. Okay, so let's have a look here. We've got 5 consecutive latte orders and a 30% probability of it being made with trim milk. So as we've got a probability and a set number of trials, it is binomial. Okay, I'll let you work those out later. Okay, the mean number of phone orders of coffee per hour received by the cafe is 4.6. So the number of phone orders, that's discrete. Coffee per hour, hour is continuous. Discrete per continuous. Reminds me of a certain cat I know. Poisson distribution. Excellent. Okay, so this last one here. So this one here, notice we're working out the mean. We've been given a table. Hopefully you remember how to enter those values in on your calculator and find your, what's it going to be labelled on your calculator? Is it labelled X bar, I believe? So yeah, that can be your question on that one. So have a go at this test. See if you can answer all of these questions. Then you've got a wide range of skills. I believe this is the 2014 paper. I'll put it on Schoology. Okay, thank you. So this is a discrete random variable, but it's neither Poisson or binomial. We need to put it in on our calculator. Okay, thank you very much. And hopefully I'll be able to stop recording in a second. Oh, this is the point where I forget how to... No...